Hello, in this video I will be showing how to create a circuit snippet in Altium, and I'll be going kind of through step by step of how you would find out what kind of a circuit you should make, through how do you get on Altium to do the actual schematic capture, and then how do you save and commit that to GitHub. Hopefully this will make it simpler for you to do work in Altium and get some more people involved in this. So basically, if you go to GitHub, this is assuming that you have already um, installed Altium, gotten me to send you an email from Altium saying that your account has been set up and that you're at least able to get the software up and running. And it's also assuming that you have set up GitHub as well, so that you at least have a copy of the repository in there for you. So how are we going to know what to do? So what we can do to start is either talk to me, talk to Kevin, or you could look at the issues that are open on GitHub. I'll be going through after I make this video and adding in the rest of the circuits that are needed to be designed. There'll be templates, sample circuit, and then we'll have this template circuit tag. And then what this issue basically has is, why do we have this circuit? What do we need it for? So this sample circuit that we'll be doing in this video is really just, how to create a sample circuit. It's just going to be like a resistor divider and really, basic. Take like a minute to draw and, use existing library components just to make it easy to do so. So when you decide, okay, I'm going to take on this sample circuit, you should probably let me or Kevin know. But then what you can do is go over here, assignees right now, make sure no one else is working on it. If there is already somebody working on it, just ask them if, you can help, or, if they need help or whatnot, or if it hasn't been touched in 2 weeks and you think, oh, maybe this person's not doing it anymore, then you can, reach out to Kevin or myself and see kind of what the status is on that. But you can assign yourself, and then you can also edit the description. I believe other users can edit the description and update comment. And now, I'm the responsible engineer for this circuit. So then you want to leave a comment to say, like, getting started on this circuit, and make a comment on that. Cool. So I guess one thing that is not in master yet, but hopefully will be later today, is on this sensor list branch, at least for now, in the admin folder. Here is the master IO list. So basically this list is all of the types of circuits that we're going to need to complete the pod. And if it wants to open in Microsoft Excel, ooh, it looks like I already had a previous copy open. So basically the way that this document works is it has just about everything this electrical system needs to perform. So there's quite a bit of it. A good portion of it is, a good portion of the data comes from the BMS and the motor controller. So those come, in our monitors that come from the battery management system directly. So we don't need to necessarily, program circuit, design circuits for it, but we do need to, handle it in software. So what I'll do next is collapse these. So, circuits of the same type are hidden, and you just see one of each. But so one of them would be like a retroreflective sensor, which is used to measure the tape strip. And then this just kind of goes through, what's the retroreflective sensor, just a quantity, a reference designator. So if you see like R1 for a resistor, U10 for an integrated circuit, um, that's what basically the number of the circuit is called. It's called a reference designator. The functional system. So basically, what does this go towards? Does it go towards navigation? Does it go towards braking? Does it go towards just general DAC? Is it a high voltage battery monitor? Um, then we divide it into high voltage or low voltage. Is it an input or is it an output? Or is it kind of bidirectional? What's the circuit type? So this one, it's a little unclear at the moment for what exact circuit we need here. Maybe I'll work on that or just do it more in the Git issues to give a better description of what needs to happen. Does it go to an I/O expander or does it go directly to the BeagleBone? Um, what pin does it go to, either on the I/O expander or on the BeagleBone? And then what does it do? It detects the tape strips. Very important thing. Why can't we cut this sensor? Tape strips are the main way that we determine pod position. So, if we got rid of it, then we wouldn't have we wouldn't have a way to determine where the pod is. You'll see that some of these in yellow are, cuttable sensors. So, we could probably do without. Um, how does this sensor affect the control loop? So that's the control loop that basically runs the pod. So in what way does this sensor, affect that? So for a retroreflective sensor, knowing how far we are in the tube would say, hey, we need to transition into braking, or we need to really transition into braking because we're at the end of the tube and, still going 30 miles an hour. So we want to, how does this affect the control loop? Um, and then another point would be to add in the signal and channel name. I'll go through these as well, and I'll kind of explain where that comes in. And then this is a little bit more on the tracking side of things. Um, so we have all these circuits, and we want to make sure that we have responsible engineers for every single one of these circuits. Kind of what responsible engineers mean is you are going to, be the person that if there's a question about the retroreflective sensor, we will go to you and ask about how the circuit works, how it was designed, and kind of how, you're responsible for delivering that kind of finished product the to the rest of the team, to who's ever designing the PCB. And then once we, get the boards back, when we bring up those boards, you'll be responsible for, making sure the circuit works, doing a test on the circuit in order to, kind of complete the job. And then this is more for tracking, but template status. So that's like, the template that I'm going to be showing you how to do today. I've been kind of using templates and snippets independently. I should probably just use snippets because templates are a different thing in Altium, but whatever. And then has this circuit been pulled into the production schematic, and has it been pulled into the production layout? So we'll be making snippets that will just be kind of independent on their own, and we'll need to pull those in to actual projects. So that's where the production is what's going to go on the pod, or at least version 1 of the hardware, and into the HIDL setup. So yeah, that's basically this document. There's like a lot of things on here. A lot of them are the same circuit, just repeated multiple times. Um, but yeah, feel free to look through this list. Um, Everything that, pending a mistake that I missed, everything that isn't in yellow over here is required to we need to have it basically, otherwise the pod isn't gonna go through, isn't going to make it through all of its inspections and its functional checks. So yeah, we just want to make sure we go through that. All right, so then getting into Altium, what we first want to do is be on our master branch. So I'm opening up git bash. That's my preferred Windows terminal emulator. There are certainly other ones that you could use, but I like this one a lot. So if you do a git pull just to make sure you've got everything up to date. So this would be equivalent to doing from your git repos folder, typing in git pull and then the URL www.github.com/whatever the link is for actually checking out and cloning the repo. So now that we've got everything up to date from master, um, then so I guess one thing that it looked like in the video people might have been a little confused about, or from that survey people might have been confused about, is um, kind of what this kind of how git bash works. So basically, this this pod4 Altium is the same as here and here they match. Um, for the most part, there are some files that we ignore, like this text document. We don't show it here because we're just kind of hiding it in Git through a thing called git ignore. So you can see like the git ignore is here. So that just says, hey, these files are like metadata that we don't really care about, so we'll just get rid of them, or not get rid of them, but we won't commit those to the main branch. A lot of times those are like generated files that we just don't need in the full repo. Um, and then I guess just the basic how to navigate in Git. ls displays the files that are visible on on the terminal or on the Windows Explorer. If you do cd src, so that's change directory and go into the source directory. So now we're in the source directory. So if we look over here, we've got kind of the same match: datasheets, history, lib, the design workspace. That's all kind of right here. So then we can do git status. So we can see that our branch is up to date because we haven't made any commits on this branch that haven't been pushed to the remote branch. And then if you want to go back to the previous folder, then you do cd dot dot. That means go back to the previous folder. And then now what we'll do is go git checkout. And then when you do this, okay, so we can do git checkout -b. That means, hey, GitHub, check out a new branch. And then we'll call this sample circuit template or snippet. And then your username or your name or just something that says, hey, this is kind of what I'm working on. Yeah, so when you do this, you want to make sure you're starting off of master and not off of a different branch, because then sometimes you'll get the commits that are from the branch that you were working on at the time, and then when you go to like commit one small little file change and get that into a pull request, it'll show up as like 45 different commits from the previous branch, and that'll be annoying, and we just want to avoid that. So now that we've done git checkout -b, then the name of the circuit, call it a snippet, and then have your username. So then now you can see it says switch to a new branch called sample circuit snippet rcastle. The nice thing about git bash, other things do this too, is that it really shows you pretty clearly what branch am I working on right now. And then you can see that it's the same thing as master because it was a clean branch that was created from master. But then when I make changes on this, then I'll commit those changes directly to my local copy of sample circuit snippet rcastle. And then when I'm ready to go, ready to push those for the outside world to see, then I'll do a git push. And then there's a command that I'll show you later, but it's git push set upstream origin slash circuit sample circuit snippet rcastle. What that does is it pushes your commits to the particular branch. So these are the different branches that are open right now. And then you can see, and we'll get to this later, but when you want to do a pull request, um, then um, crap. Okay, so now this is what you will see when you go to do the sample. So you'll see this design repository. So you'll have seen this before probably. But what we're going to focus on down here is this snippet project. Um, so usually in industry, if you're making a circuit snippet, you're taking a circuit that's already on a existing product and you just want to reuse it on a new product. Um, but in our case, we're going to make that first product as like a separate separate schematic sheet. Um, so what we're going to do is say, hey, I'm going to work on the sample circuit. Um, so if you don't see your project name in here already, you go right click, add new to project, add the schematic, and then you want to be sure to save right away and call this sample circuit. You want to make sure that you're saving to the correct folder and file location. Otherwise, when somebody else goes to open this up, they might not be in the same location. So you can see I'm under Documents, Git Repos, Pod4 Altium, Source, Template, Snippets. And then you can see, you want to save over here. A lot of the time it might auto save to like the public documents Altium folder. And we don't want to do that because that's not really part of the repo of Git. So when you go to commit that, it might not find it, and then you only have a local copy on your machine. And if you fall off the face of the earth and can't find you, then all of your work was lost. So we want to make sure everything's in GitHub and in the proper folder location. So yeah, we're calling the sample circuit and we'll hit save. So then one thing that we've got here is we've got our libraries. So this will be something that you won't have to do. But if you need to add in a library, say to a new project, and you want to use the existing libraries, you can say lib, and you can add in the libraries that we want. And what this allows you to do is access to these components. So we want to have access to all of the components and kind of go from there. So on the sample circuit, basically what we're going to do is, now we're finally able to, start our sample circuit design. So in this case, this will be really quick because, I'm just going to do a really basic circuit. But in your case, this might take, a while. You might be looking up data sheets for components. You might be, doing, real circuit design, which might take a little bit of time. But hopefully, look at the requirements and kind of go from there. So if the circuit needs to do X, Y, and Z, then then see what the circuit, see how you would design that circuit to perform what you want. Um, yeah, so circuit design it's not trivial, but I think doing it in a way that is really bite-sized like this will be hopefully valuable to hopefully it'll be valuable to everybody. So I guess just a couple things as I'm going through this. Um, a couple guidelines when we're making hopefully generalizable circuits. we want to, follow some, guidelines. So what your grid, and if you don't know a command in Altium, you can, go up to this search bar and, type it in. It's new to Altium 18. It wasn't in Altium 17. Um, but then what we want to do is be on the Altium presets for Imperial, and we want to be uh, in this grid. Um, so we want to be, this is our snap grid at 50 mil. Get out of here. Slack is annoying. Sorry about that. I hope Tristan and I weren't talking shit about people or whatever. Um, Kevin, can you cut that out later? Um, you can see my impatience because Slack use like half of my RAM, which is really stupid. So yeah, just make sure you're on the 50 mil snap grid. I believe that that's the default. So no, it's not actually. It's actually on course. Yeah, course 3 is where you want to be set to for the Imperial, for the setups for the snap grid. And then that will, kind of be the standard way. So when you're doing, you're placing components like this, it's always helpful to place them on the, these are every 100 mil maybe. I can't tell. Whatever, place them on the darker lines. Just gives your schematic a much cleaner look. And then you also want to, place your components kind of in the middle, um, of, vertically. You want to align them horizontal, you want to align vertically so that, everything just lines up, looks nice, is really easy to follow, and you don't have, components. Same thing if you wanted to do this, if you wanted to do a horizontal component, um, but, we're just going to do a vertical one. And then now it's kind of time to do the fun part of, actual circuit design. So I'll just design this circuit. So we usually say positive 5V instead of plus 5, mainly just for net lists, but you just want to make sure you're checking that out. And then some of the shortcuts you don't really need to learn, but if you want to, that's totally fine. So PO is place a place an object, and then we want to place grounds. PN is place nets, and then we'll call this voltage divider 1. Voltage divider 1. So depending on the specific circuit and how we'll integrate that into the full project, I might be able to have net names. So from that Excel spreadsheet where it had the channel name, if that's defined, then you can call this circuit retro 1, retro 2, retro 3, and then we'll have that you can have multiple circuits on one circuit snippet, or you could just leave it generic and call it uh, just say 1, 2, 3, 4, 5. You could leave it as X. Well, actually, you don't want to leave it as X, but you want to just give it kind of a generic name that you'll be able to pull in. And then one thing with this is we'll want to keep all of the reference designators as just question marks. So that way, um, actually, this is kind of debatable, but I would say keep all of your reference designators as question marks, so that when you're pulling into a full project, you'll be able to just annotate that very easily. So now this is our full circuit design. So basically all this is a voltage divider. Um, so this will be not quite half of positive 5 volts at VD1 because the voltages, the resistors aren't exactly the same. And then just a little filter capacitor here. These values are just, made up from the library. So don't actually copy the circuit for anything. So now when we want to actually go to make the snippet, what we'll do is, control save or do right click save on sample circuit schematic document. And then what we'll do is select all on the circuit, and then right click and go to snippets, and then say create snippet from selected object. Then we're in here, we're in snippet, we're in the snippets folder. This snippets folder is underneath the templates folder of our repository. So if you look at the templates folder in here, you can see snippets. So these are all of the all of the source documents for a snippet, which are all, correspond to be right here. And then we'll give this a name. So we'll call this voltage divider. And then a comment, voltage divider for sample video, and hit OK. So now that we've got this saved, that's pretty much all we need to do. So yeah, so now what do we do? So what's kind of the next step? So the next step that won't be taken right away, but the next step from like a project perspective is to look at, is to go into the actual project. So this is like the power PCB. So this board is, in review. It's kind of fun to scroll around and stuff. It's annoying. I'm on a laptop touchpad, so not super great connection. But yeah, so what we want to do when we want to go to place a circuit snippet is go place. It's actually to go down to the snippet panel. You can access that by going down to panels and then selecting snippets, and then going to the snippets folder. Sometimes you may have to go open folder here and then navigate to here. I already have this set up, so it's already done for me. But if you just go to snippets and say OK instead of cancel here, then it will find this folder, and then we can go in. Okay, we've got our voltage divider, and we can go place voltage divider, and then we can go and place that in our circuit. Yeah, so that's pretty much that for how to actually do the schematic capture. So I'll get rid of that, and then I will not make these changes. I will not save these. Yes, one thing in Altium, you want to be very careful about what you're saving and what you're not saving. So like these were some changes that were made previously, but I don't want to actually commit those on here. And then I will save this design workspace here. We could probably edit this part out later. Don't do any of this. Pulls. Don't do this part. I just messed up the project structure a little bit. So yeah, don't mess with this unless you like know that you need to add in these extra files. Um, so I guess one other note is that if you are adding, if you're doing a schematic design and you need to add in a library component, one option that you have if you're actively working, and going on a schematic is to go into the temporary library and then, add in your components in here. So like uh, place pin, make your place rectangle, uh, place everything, do all that fun stuff. And then, you can use this temporary library and then there are some things that you can do in order to merge that into the main libraries later on. So the idea is you don't have to go to to the libraries branch and then make one tiny little change, jump back to this branch, realize that uh, want some more space between pins or messed up a pin out or whatever it may be. So you can work in the temporary library branch and commit those to your particular branch. And that's totally cool and totally fine. But then at some point, we'll want to get your temporary commits, your temporary library files into our main, libraries, capacitor, connector, IC, inductor, miscellaneous resistor, and kind of get those all into one place. I realize now that inductor is misnamed, but that's fine. Um, so again, don't do this. Don't save the design workspace unless you like add a new file. I didn't do that when I was setting this up, but that's fine. I hate Slack. Um, yeah, so that's pretty much it on the Altium side of things. So I'm going to close out of Altium, um, and then now I'll just run through how to commit your changes, and then how to kind of go from there. So I'll do ls, and then you can see I'm still in my branch. I'll do git status, and so you can see that there are a few changes, few files that have been modified. Um, so what we will do here is go, so the files that we care about are, and this is the first time I've actually gone this far, so, because I wanted it to be fresh and everything. So we added in our circuit snippet PCB project. We modified our temporary library file, and then we added in, the voltage divider, schematic document, the snippet icon, the snippet thumbnail, and then the sample circuit schematic document. Um, so those are all fine to commit into here. What I may do is divide these up into more files, although there are already a lot of files on GitHub, so maybe not, I'm not sure. Um, but very similar, structure that you'll see set up here. And then in this case, I'll do git add src-templates snippets. And then if you want to add in all of the files in a particular folder, you can go slash. Um, and slash will add in all of the files in that folder. Uh, so you can see, so you really want to be careful here. You really want to check, are these files the ones that I really want to be adding and changing? So voltage divider, schematic document, sure. The snippet icon, snippet thumbnail, those are all fine. Not quite sure what the index file is for. We might want to ignore that later on, but for now, it's fine. Um, you shouldn't have to worry about that. We added in the um, sample circuit project, then um, you won't have to commit the snippet project. If you do add in a new, full file like we did, then you'll have to save the snippet project, PCB project, and then if you modify a library, then you'll also have to work with that. Now, usually you won't have to commit the design workspace, and then Here's a good example of, so we made a change on the Power PCB project that we don't actually want to commit. Um, Realize the DMs with Tristan are wide open, but I'm pretty sure nothing matters. So whatever. I really hate Slack. If you look at like Task Manager and wonder why your computer is running slow, it's probably because of Slack or Google Chrome. Um, so now that we've committed this, we'll go, well, sorry, we've added the files we want to commit, git commit -m, and then we'll add in this message going through sample, you know, going through sample snippet project. Okay. So then you can see the files that it made new, and then just the ones that it modified. And then we'll go git status, and we'll see that we still have these files that we didn't want to commit. And then we'll do git push. And then the first time you're on a new branch, you have to tell your local copy of the branch, hey, what am I going to point to, upstream? So you can really just copy this message. And now that we're pushed, so you don't really have to look at this, but it's good confirmation. We made a new branch. We called it sample circuit snippet our castle, and that points to sample circuit snippets. I can't even say that. Sample circuit snippet our castle, and then we're setting up to track the remote branch. So now if we go into GitHub, and then we'll see, hey, I made this change. What you want to do is go into your issues and say, created video, so you want to just kind of keep this issue updated with kind of what you're doing. If you're running into trouble, if you're not sure, if this particular circuit is designed correctly, you can even, upload an image of your schematic and say, hey, is this, is this right? Is this what I should be doing? Then when you're ready to, make, so now I'm done with this. This was a really easy circuit to make. But I'll do a pull request. So we don't give everybody access to the master repository, mainly just so in case anything goes wrong or you inadvertently change something, then we don't accidentally we don't accidentally destroy everything. So I'm going to hold off for 1 second before I make the pull request because I will throw in the design workspace changes as well. And we'll just do that all at once. So once that gets pushed, we'll see, hey, now I've got our 2 commits. I've changed 9 files, which seems like a lot. And then this is where, GitHub is a lot better at reviewing code than it is reviewing, all these binary files. Makes it a little difficult to review schematics, which is why it's important to leave really descriptive comments on, what was changed, because it's not like, code. You can see here, if you've never used Git before, you can see that, these are the files that were modified and changed. and what was inserted, what's new, what's not new. Um, so that's for like text files. For binaries, which are what Altium uses, it's not able to preview that. So when someone goes to review the pull request, they actually have to open up Altium and look through all the changes. And yeah, so it's really important to be careful on what you're changing, what you're committing, and the files that you're kind of going with. Um, but just be careful, and hopefully someone will catch it in review on the pull request. So definitely, if someone has comments on your pull request to say, hey, can you improve this? Um, just try to work with our system. We're definitely trying to let this run as smoothly as possible and make this run as smoothly as possible and not make it a really blocker for anybody to work on it. But we also want to, use GitHub to, to provide some checks and some assurances that we don't build hardware that's not going to work because, we made a stupid, mistake, or you didn't know something and, we just missed it. So we just want to kind of have this check here. So I'm going to leave my comment and say, uh, made a few changes to uh, made a few changes to the sample circuit after going through video. This is actually the first time that I've used a snippet, so I'm pretty new to it, but it's pretty basic, I think. And then um, yeah, that's pretty much all I need here. Okay, so definitely, I'm going to make a pull request and then, just show you kind of how to do that. Um, but then, I'll go back later and delete the sample, or maybe I'll leave it up for a while just so, you can look at it. Yeah, maybe I'll do that. So I'm going to create this pull request. You can see, if you join the GitHub channel, you can see, hey, this pull request was made. And then when you get to this point, you'll see review required, merging is blocked. So up until a few days ago, master was open, anyone could commit to that. But now that hopefully more people will be working on Altium and in Git, we want to have pull requests that are reviewed by people. So when you make a pull request, this is kind of what it looks like. Like, what are the commits? Um, what are the files changed? Is there any conversation on it? So you can leave comments, or somebody might comment back and say, oh, could you, change your resistor value on R7? Could you do X, Y, and Z to make this better? Or, hey, you accidentally committed file changes that probably shouldn't be included in here. Can you delete those, or whatever it may be? Um, so that's kind of where the comment on the pull request might come through. You can request reviewers. So whoever it might be can kind of look through the list. Um, have Tristan review this one. Um, and then, yeah, that's about it for doing circuit snippets. I think so. Hopefully, that'll be easy to go through. I'll be going into the issues tab later today, although the Badgers football is playing, so maybe I don't know. Maybe I'll do that tonight. I'll probably do that tonight. Um, and then, yeah, hope to get more people going on Altium and doing schematics and circuits and stuff. If you have any questions, let me know. Thanks. Sorry for all of the screw ups that I made in this video, but I hope that gets the point across.